In this video I introduce you to a couple of special sequences. We're going to learn how to use those special sequences to find functions for our sequences that they are similar to. All a little bit confusing, but in the exercises that go with this video I will actually tell you which sequences to compare to. So look, we've done this sort of thing already. If we know our sequence is similar to another sequence, we just need to find out what we need to add or multiply to obtain a function for our sequence. We did that with our linear sequences previously, so we thought, well, you know, this sequence is just like the 5 times table, but they're all 3 more, so the formula is 5n plus 3. So that's what we're going to do with our special sequences, and they'll be ones that don't fit the times table pattern. Now the difficulty is finding out which sequence you need to compare to, and the exercise in this video, it tells you which which sequence you need to compare to. Okay, so let's look at an example. We want to find the sequence or the function for this sequence 3, 6, 11, 18, and I've been told already that this one I can compare to square numbers. Well, square numbers go 1, 4, 9, 16, 25, and if we look at this number here, well, to get from 1 to 3 I can do one of two things. I could multiply by 3 or I could add 2. Now let's look at the 4. To get from the 4 to the 6, well, I could multiply by 1.5 or add 2. Well, obviously there was a change on the multiplication, but adding 2 was true in both cases. 9 add 2 is 11, and so on. So we know that the sequence for square numbers is n squared, and we know that we're always adding on 2 more, so our formula is going to be n squared plus 2. Okay, so here's one more example, and this is 5, 15, 30, 50, 75, and we're told to compare this to triangular numbers. Okay, so the triangular numbers go 1, 3, 6, 10, 15. We're going to use the same approach again. If I multiply this by 5, I get 5. If I add 4, I get 5. So the two things I'm going to consider are multiplying by 5 and adding 4. Well, let's look at the 3. If I add 4, I get 7, not 15. But if I multiply by 5, I do get 15. So it looks like multiplying by 5 is the thing we need to do. Let's just check with the others. 6 multiplied by 5 is 30. 10 multiplied by 5 is 50. And 15 multiplied by 5 is 75. So it looks like our sequence is the same as the sequence for triangular numbers multiplied by 5. Well, the nth term for triangle numbers is this one here, and it tells you that in the book that goes with this video series, and we know that ours is 5 times more, not 5 more, 5 times more, and that implies that our formula is 5n over 2 times n plus 1 rather than just the single n there. I hope you found the video helpful. The video goes with a book that I'm writing for Year 9 Mathematics in New Zealand, and you can find a link to a copy of the book below, and that book is free for you to use and give to others. In the book you can find questions that go with this video, and in a link below this video you'll be able to find answers to those questions. Stay in Winfield with Winfield.